Okay, so now we have enough information to graph these rational functions without a graphing calculator, or at least, get the basics of it correct. So let's just summarize, because we already know how to find the domain, the intercepts, the asymptotes, and then now the rest is just to put all these pieces together. So these are some guidelines that I've summarized. Your book might actually, have this in a slightly different order, but this is the way I suggest. So, given a rational function, that is a fraction of polynomials, p and q, we first factor the polynomials. We find the domain by setting the denominator equal to 0. The domain is going to be everything except those solutions. Then we write the function in lowest terms. That's cancel any common factors. We find the x-intercepts by saying the numerator equal to 0. We plug in x equals 0 and get the y-intercept. The vertical asymptotes are what is when the denominator is 0. And we compare the degrees and find the horizontal asymptotes if they exist. Then we plot the intercepts and the asymptotes, and we draw the asymptotes. Then the only thing left is to see, well, where's the graph above and below the x-axis? Well, that's really about where's the function positive and negative. And if we know the signs of all the factors, then we'll know the sign of the whole function. And the only time that this function will change sign, and the only time this graph will switch, either cross the x-axis or change sign, is when the factors change sign, which was when the factors will be 0. So one way to do this is just to make a sign chart and just the only places that a rational function can change sign will be at the x-intercepts, that is if our graph is crossing the x-axis, and vertical asymptotes, where maybe we're shooting up on one side and shooting down on the other. So then we list we just consider those numbers that correspond to the x-intercepts and the vertical asymptotes, put them all on the x-axis, and see where the function either changes sign. If it changes sign, they'll change sign at those points. So what you could do is you could take these points, will divide the x-axis into intervals, and then pick a number in each interval, plug that into the function, see if it's positive and negative. Okay. And then that's one way to do that. Another way to do that is to make a sign chart using the factors, which we'll do maybe a little later. And then we put everything together and we sketch the graph. Some things to remember: a graph can touch a vertical asymptote. It doesn't have to, but it may. The graph can never touch a vertical asymptote because the function is undefined at that point. And if there are any open circles or points, that's going to be the point where the numerator and denominator are both 0. Okay. All right. So let's look. We're going to do several examples. First one, example 1. Let's first factor. Well, the numerator is already factored. The denominator factors is x plus 2, x minus 2. Okay. So right away we know the domain is all x not equal to 2 or negative 2. Right. Now this is all none of these factors cancel, so this is all in lowest terms. Then we find the x-intercept. With the x-intercept, we set x minus 1 equals 0, we get 1. And the y-intercept, we plug in 0 here, we get negative 1 over negative 4, so that's positive 1/4. If I plug in x equals 0. The vertical asymptotes, we have 2 of them. At x equals 2, x equals minus 2. And the horizontal asymptote is going to be compare the degrees. Degree is bigger on the bottom, so the horizontal asymptote is y equals 0, the x-axis. Okay, so then we can plot these points in these asymptotes. We'll do the vertical asymptotes first at 2 and negative 2. And then we have the horizontal asymptote is the x-axis. We have an X-intercept at 1. And the y-intercept is 0, 1/4. Alright. Now we still need to find out where is this positive and negative. Where's the function positive and negative? So let's see. We have an asymptote at negative 2, 1, and 2. Okay, and let's see what happens. If x is really, really big, if it's bigger than 2, then you should convince yourself that all these three factors will be positive. So the graph will be positive. And then, but when x is when x is less than 2 and bigger than 1, but maybe I should just write this out. Okay. When x is between 1 and 2, this is still positive. This is still positive, but this will now be negative. Okay, like plug in 1.5, you'll see that this is negative. And then when x is between negative 2 and 1, well, you can plug in 0 or you can do a sign analysis. You'll see that this is negative, this is positive, and this is negative. So this will be positive. And then when x is less than negative 2, you can plug in negative 3, or you can just see that all three factors are negative, so this is negative. So this tells us that the graph is below, then above, then below, then above the x-axis. Okay, so we do this, let's look and see. In particular, well, let's look at this. We know that for this interval, the graph has to be above the x-axis, and that means it's going to be shooting up on the right side of 2. Okay, and we go because we have a horizontal asymptote, which is the x-axis, is going to come down like this. Okay, now from negative 2 to 2, let's see what's going on. We are above, and then we're below. So that means that at negative 2 on the right side of negative 2, we're up here, and the graph will have to come down, hit the intercepts, and then between 1 and 2, the graph is below. And then finally, we can see the graph is below the x-axis when to the left of negative 2, and so the graph will look like this. Okay, and that's as good as we're going to get. There's no turning points in this case, and that's about all we can do with this without a graphing calculator.